Hello there, welcome to Omeed Private High School online class. In this class we are going to cover some remaining topics of 10th grade physics. As you know dear students, in previous classes we covered special rays in concave and convex mirror and importance of those rays also we discussed. Today we are going to talk about image formation in spherical mirrors. First of all, image formation in concave mirror. Okay. First case, if the object is at infinity, image is formed on focus as a point. Okay, you know concave mirrors are the mirrors in which outer surfaces are painted, inner surface reflects. Okay, here this outer surface is painted. Okay, this outer surface is painted, inner surface is shiny surface, inner surface reflects rays. Now in previous classes also we discussed that we need only two rays for image formation. Okay, let's use this concept here. If the object is at infinity, then we said image will be formed as a point on focus. Now here we use special rays for image formation. Okay, what was one of the special rays? One of the special rays was that if the incident ray is parallel to principal axis, okay, if it is parallel to principal axis, then we say that it will pass from the reflection ray will pass from focus. Remember? Okay, now this one will be reflected this way. This reflected ray will pass from focus, as you see here. If we use another special ray from this side, okay, let's take it is parallel to principal axis. You know this is principal axis. Then it will be reflected in such a way that it passes from focus. You see, the intersection point of reflected rays shows the image formation. Now image is formed over here. Okay, you see over here image is formed as a point here. So we say that if the object is at infinity, then image will be exactly on focus, but it is as a point. Here you see this note. Concave mirror is also known as converging mirrors. Okay, you see how we can say they are converging mirror. As you see here, the incident rays will be converged at one single point. You see, after reflection they meet each other at this point. So this mirror, this concave mirror converges incident rays. Okay, that's why we can say that these mirrors also known as converging mirrors. Converging mirrors means متقارب كونكي. Okay, let's move on. Second, if the object is beyond C, image will be, how image will be formed? Again, we use special rays. Okay, now let's use special rays. One special ray is parallel to principal axis and it will be reflected back in such a way that it passes from focus like this. Okay, and another special ray was that if an incident ray passes from focus, how it will be reflected? Remember, it reflects in parallel to principal axis this way. You see, this parallel to principal axis. Now where image is formed, this point of image is formed here. This point of object, image of this point of object will be here. Now how we know? Because incident rays which are coming from this point intersected each other at this point. Then here is the image formed. Now let's draw image here. This is image. Okay, you see image is inverted, it is smaller, and it is real. How do we know it is real? It is real because only real rays intersect each other to form this image. You see the properties of image now. Image is between F and C here. You see here also it is between F and C. It is real. How do we know it is real? It is real because real rays intersected each other to form image. These rays are not imaginary. They are real reflected rays. It is inverted. You see, it is inverted. It is smaller. Smaller than what? It is smaller than object. Okay. Okay, now let's see this diagram here. Assume this candle is object. How its image will be formed? You see it is located in front of one concave mirror, and its image is formed exactly here. You see image is formed here, and it is between F and C, real, inverted, smaller. Okay, let's continue. Third case. Okay, you see third case. If the object is at C, okay, if the object is at C, then how the image will be formed? Again, we have to use special rays to form images. Okay, now let's use special rays. What was special ray? One special ray was that incident ray is, if incident ray is parallel to principal axis, then how it will be reflected? You remember, it will be reflected from focus. Okay, next, another special ray, if the incident ray passes from focus, then how it will be reflected? Remember, it will be reflected from in such a way that it will be parallel to principal axis. Let me draw as accurate as possible. Okay, okay, now it will be reflected parallel to principal axis. You see it is parallel to principal axis. Now image is here. Okay, image is here now. Little discrepancy is here. Let's try to solve it. Where is the problem? Maybe this may not be parallel, that's why there is some discrepancy. Some inaccuracy is 0. Okay, let me try to solve it. Okay, if it is okay, let's say it is parallel to principal axis, it will be reflected back in such a way that it passes from focus. Okay, another special ray. Sorry, it will be reflected back parallel to principal axis, right? Okay, now this is, yes, almost correct. This is the image formed. Now let's see the properties of image here. Okay, image is at C, same size, inverted. You see, at C, it is at C, it is real. Inverted, you see here it is inverted, same size. Okay, now let's see this one. You see, object is on C, its image also exactly on C. Okay, let's continue. Fourth, if the object is between F and C, image is, how will be the image? Okay, let me show you the properties of image. Okay, first property is that it will be beyond C, it will be real, it will be inverted, and bigger than what? It's bigger than object. Okay, let's try to draw the image. Again, we have to use spatial rays, concept of spatial rays. Okay, I hope it's parallel. Okay, it's parallel to principal axis and it will be reflected from focus, right? Yes, it will be reflected from focus. Next, another special ray which passes from focus. If it passes from focus, how it will be reflected? It will be reflected parallel to principal axis. Okay, let's assume it is parallel to principal axis. Now let's draw image. To real reflected rays intersected each other at this point, then here will be the image. Let me take a different color. Okay, now okay, you see, this is the image. See the properties of image. Here is the C, image is beyond C, it is real. How do we know it is real? We know it is real because it is formed by the reflection of real reflected rays. Okay, next, it is inverted. It is inverted, yes. Bigger, yes, it is bigger as you see here. Okay, let's see this one also, then we move to next one. You see, this candle is located between F and C in front of one concave mirror. Then its image is formed just here. It is bigger than object, it is inverted, it is real. Okay, let's continue. Fifth case, if object is between PF, the image is, you see, what is P? P is this point, remember? Or we can say this point. Let me show you. Center of mirror itself is known as P, right? Center of mirror itself is known as P, or pole. Okay, if the object is between pole and focus, as you see here, then what will be the properties of image? Okay, let's see here. Okay, it's behind the mirror. Okay, behind mirrors means this side. Okay, next property, it is upright. Okay, it is upright. Next, it is virtual and bigger than object itself. One special ray was, you remember, it was parallel to principal axis, like this way, right? parallel to principal axis. Okay, let me take another line, smaller size. Okay, one special ray was parallel to principal axis. Okay, let's take it. This is parallel. This incident ray is parallel to this principal axis. You know it will be reflected from focus only. This way it is reflected from focus. This is reflected ray, this is incident ray. Another special ray was, remember, if this incident ray comes from focus, right? If it comes from focus, then it will be reflected from, how it will be reflected, remember? It will be reflected parallel to principal axis. You see, incident ray has struck here, then it will be reflected parallel this side, parallel to principal axis this way. Okay, now you see this is one reflected ray, this is another reflected ray. They never intersect each other, right? They never intersect. Then if they do not intersect, there will not be image. And what should we do for image formation? For image formation, we should extend these incident rays. How do we extend? You see, this is one incident reflected ray, so we extend this reflected ray to behind the mirror. This way we extend it. Extend means we just draw some imaginary rays. Next, we should extend this reflected ray also. This is also reflected ray. Now we extend it. You see, extend means we just draw some imaginary rays this side. This one and this one, they are imaginary rays and they have intersected each other at this point. So here image is formed. Okay, let me draw image. Okay, this is image. Okay, if we extend this principal axis to this side, if we extend it to this side, this is image, dear students. As you see, it is behind the mirror, it is virtual. How do we know it is virtual? It is imaginary. Virtual means imaginary. Imaginary means it is formed by the intersection of imaginary lines, imaginary rays, right? It is upright, it is bigger than object itself. Okay, let's see this one also, whether we have done it is correctly. Okay, you see this is object, image is formed here. Alright, now let's continue. Okay, image formation by convex mirrors. You know, convex mirrors are the mirrors in which inner surface are painted, outer surface reflect incident rays, right? And here we talk about image formation by these kinds of mirror. Okay, let me paint inner side. Okay, okay, painted inner side. You can do it better than this. I'm sure, dear students, you can do it better than me. Okay, first, if the object is at infinity, image will be on focus as a point. Okay, if the object is at infinity, now let's draw special rays here. How? You see here, one special ray is parallel to principal axis, right? Let's take it parallel to principal axis. How it will be reflected? Remember, it will be reflected in such a way that you think it is coming from focus, right? Now this is reflected ray. Next, If incident ray is parallel to principal axis like this, okay, how it will be reflected, you know, it will be reflected in such a way that you think it is coming from focus like this. Okay, now this is reflected ray. This is reflected ray, right? You see this reflected ray and this reflected, they never intersect each other, this region. So in this side they can never form image. Then you see here we have extension of this reflected ray and here extension of this reflected ray. Then extension intersect each other at this point. See, in the extension of these two reflected rays, this ray and this ray intersect each other at this point, then image is formed at this point as a point. You see this note? Convex mirrors, also known as diverging mirrors. Okay, how we can say they are also diverging mirrors? Because you see these incident rays are diverted from each other. Okay, they are just diverted from each other, they just reflected away from each other, they never intersect each other, they are just away. Diverging means mutabaid. Okay, let's continue. Second, if the object is between the mirror and the infinity, the image is always okay, always formed between if and pp, you know, pole of the mirror. Pole means this point, okay, center of mirror itself. Virtual image will be virtual, image will be smaller than object, and image will be upright. Okay, here it is very important. If the object is between mirror and infinity, anywhere this region, okay, maybe on C dash, maybe on F dash, maybe between, maybe beyond C, anywhere, the properties of image will be same. Okay, let's take one object this side, anywhere. Okay, let's take one object. Okay, let me draw one object here. This is the object. Okay, now let's draw image of this object. Again, for image formation we have to use special rays, right? Okay, let's draw some special rays. One special ray was, you remember, parallel to principal axis. This is principal axis, parallel. You know how it will be reflected. It will be reflected in such a way that you think it's coming from focus like this. Okay, now this is the reflected ray. This is reflected ray of this incident ray. Another special ray was, you remember, if incident ray makes one angle with this principal axis, then reflected ray also will make same angle with principal axis, right? Let's take it, same angle with these two angles same. Now you see this is one reflected ray, this is another reflected ray, they never intersect each other. If they never intersect each other, they cannot form image. Then what should we do? We should take the extension of this incident ray to this side. Okay, let me use some other color. This is extension of one incident ray and this is extension of this incident ray. Okay, now these imaginary rays or extension of these reflected rays intersect each other at this point. You see this point, at this point they intersect each other, then here image is formed. Here image is formed between F and P. Okay, let me draw the image. Okay, now this is the image, dear students. Okay, let me take some other color. this is image. Okay, this is image of this object. If the object would be here, here, anywhere to this side between mirror and infinity, then image is always between pole and focus, like this. Okay, thank you so much for your attention. In the next class we will continue from equations of spherical mirrors.